Calculating compass heading and time en route. We're given this problem. It says refer to figure 24, determine the compass heading for a flight from Allendale County Airport on Area 1 to Claxton Evans County Airport on Area 2. The wind is from 90 degrees at 16 knots and the true airspeed is 90 knots. Using your plotter and a highlighter, draw a line between the two airports. I have used a blue line. We could use the plotter to determine the true course and then adjust for the magnetic variation. But we can use a shortcut. Notice there's a VOR about a mile from the Allendale Airport. We could use that VOR to determine our magnetic course, since the radials from the VOR are magnetic. So all we do is move our blue line to go over the VOR without changing its heading. I draw a red line to indicate the displaced blue line, and we can see that our magnetic heading is 214. We now have to use our E6B to determine the wind correction. So place the center of the wind window in the 150 mark and rotate the window to match the true index with the wind. We know the wind is coming from 090 degrees, and since its velocity is 16 knots, we are going to place a mark on the 166. Next, we rotate the E6B to match the true index on top with our desired magnetic course, which was 214. Now we slide down the window until the mark coincides with the 90 knot mark, which is our true airspeed. Notice that the mark is on the 9-degree mark to the left. So we need to correct 9 degrees due to the wind. And since left is least or less, we are going to subtract from the original 214 degrees magnetic course the 9 degrees wind correction. And that gives us 205 degrees magnetic heading. Therefore, the answer should be B. The next question uses the same parameters, and they are asking us how long does it take us to get there. Going back to your E6B, you can see that the hole or the center of the window is in the 97 mark, which means our ground speed is 97 knots. Now we have to determine the distance. Because the figure is not to scale, we will need to get a bit creative to determine the actual distance. Using a ruler, measure the blue line. Then transpose that blue line to match one of the black vertical lines that represents latitudes. And measure it down and count down the number of notches it has. I painted a green line to indicate such distance. Notice I began at the top of the quadrant, and if we extend down to match the same length of the blue line, the green line ends right below the text of the restricted area 3005 Charlie. Each notch is 1 nautical mile, because 1 minute of latitude is 1 nautical mile. And in each quadrant, there are 30 nautical miles. So if we count down how many notches we have in the green line, we end up with 57. So we have a 57 nautical mile distance. Now we can use our regular formula. If we fly 97 nautical miles in 60 minutes, how long does it take us to fly only 57 nautical miles? So we multiply 57 times 60 divided by 97, and we come out with 35.2 minutes. Now remember, the instructions say we need to add 2 minutes for climb out. Therefore, it will take us 37 minutes total en route, which means the answer is also B.